Hello and welcome again. So the topic which we are going to discuss today is loan amortization schedule. Before it we have seen capital recovery factor. So capital recovery factor basically it helps us in calculating equal periodic installments. So loan amortization schedule also helps us in calculating that in installments. It also helps us in that particular thing. So mainly it helps us, it shows the breakdown of each periodic payment into principal and interest over the life of the loan. Means through capital recovery factor we'll get CRF, and that CRF, when we here also formula is written, if you can see, EMI equals loan amount into CRF. So we'll get CRF, then through CRF we can multiply this capital recovery factor with the loan amount and we'll get equal installments. So here we are getting only installment. How that installment can be break down into principal and interest? What is the breakdown of that? Is in each period, monthly, yearly, what amount we are paying as installment, what is that amount, how we can divide it into principal and interest. That whole schedule can be created with the help of loan amortization schedule. We'll create a complete table and how that amount has to be paid. Okay, amortization basically means the action or process of gradually writing off the initial cost of the asset. Okay, initially some amount was there. Okay, then a person is paying that amount in equal installments. So how it is getting written off? How much amount has been paid, then what is the balance, then how much is paid next month, then what is the balance. Okay, and that amount which is paid, in that also what is the breakdown of principal plus interest. That we'll create a whole table here with the help of loan amortization schedule, and then we'll see it how the actual loan is paid in installment, and in the last the balance should be zero. Means in the beginning that will show the initial cost of an asset, means overall cost of the asset it will show, and then in the last the balance should be zero because it should be completely paid. So that's we are going to see with the help of this. So let's understand it with the question. So here simply I have taken this question. Loan amount 10,000 rupees is given, time period 3 years given. Loan amount is given, time period 3 years, that is N is 3 years, and interest rate, that is R, is 9%, or 9% can be written as 0.09, that you all know. Okay, 9%, that means 9 divided by 100, that will be 0.09. So we have N, we have R, we have this loan amount. Okay, loan amount 10,000 rupees. 10,000 rupees. Okay, yeah, loan amount is 10,000 only. So we have to find EMI as well as we have to create loan amortization schedule, LAS we have to create. So first we'll find loan amortization schedule. How we can find it out? Let's see. For loan first we have to find out EMI. So for EMI, you remember, first CRF we need to calculate, because for EMI we need to multiply CRF and then loan amount. Loan amount we already have 10,000. First we need to calculate CRF. So for CRF we have the formula. If you remember, in the previous class we have already covered this topic in the previous session. CRF, we have the formula R multiplied by 1 plus R to the power n, then divided by again 1 plus R to the power n minus 1. Here is nothing monthly or yearly, so simply N is 3 and R is 0.09. So we'll put everything in the formula. That will be 0.09, 1 plus 0.09 to the power n is 3, then divided by 1 plus 0.09 to the power 3 minus 1, and then when we'll solve it, we'll get finally with the calculator 0.3951. So we need to calculate EMI. So for EMI we have loan amount, that is 10,000 rupees, and CRF that we have already calculated. Multiply this CRF 0.3951. So we will get 3,951 rupees as EMI. This will be the EMI. Okay, I hope it is clear to you. Now we have to create loan amortization schedule. For that we need to create a table. So like this, we need to create a table. End of year. Okay, how many years are there? 3 years are there. So we can write it as at the end of 0 year, means initial time only. Okay, we'll start it with 0. Then first year, at the end of first year, end of second year, end of third year. Then payment means end of each period, how much amount we are paying, that we have already calculated. EMI is 3,951. So initially we are not paying anything. End of first year means every year we are paying. So here it is annual installment, so it will be same. This 3,951 we are paying. So we get to know only about this with the help of CRF, because CRF we'll get, then we will multiply it with the loan amount, we'll get this installments. Then interest. In the beginning there was no payment, so interest and principal repayment both will be 0. Then outstanding balance. In the beginning the loan amount was 10,000, so balance is 10,000 only. Initially the balance is 10,000 only. Okay, so it is 10,000. Now the main thing starts. Now at the end of first year, payment will be 3,951. Now this interest we know it is 0.09 or 9%. So this interest we'll calculate with the 0.09 multiplied by 5. 5 means the 5th column. I have given column numbers also. First column, second column, third column, fourth column and fifth column. So we need to multiply this rate with the outstanding balance, previous outstanding balance. So 10,000 was the outstanding balance. So we multiply 10,000 multiplied 0.09, we'll get 900. So out of 3,951, 900 is the interest and remaining 3,051 is the principal. 3,951 has to be paid equally at the end of each year. We need to pay this 3,951 only. So out of this 3,951, 900 is the interest and 3,051 is the principal. Simply this principal repayment we'll get with column number 2 minus column number 3, means total payment, total periodic payment. From that we have to subtract the interest amount, we'll get principal repayment. Now outstanding balance, this also fourth column, 10,000 was there, so 10,000 minus 3,051, because here we are taking 10,000 principal amount only. 10,000 is the principal amount without interest, so we need to subtract only principal amount here. So 10,000 minus 3,051 will be 6,949. Now at the end of second year, payment 3,951 same. Now third column, interest 0.09 multiplied by 6,941. Okay, 6,941, find out 9% on it, you will get 625 after rounding of the decimals. And here principal repayment, out of 3,951, if 625 is interest, then payment principal we are left with 3,326. And now out of 6,949 was balance. Now 6,949 minus 3,326 minus this amount, you will get 3,623. Now this is the balance. Initially the amount was 10,000 loan amount, so we have paid, then we are left with 6,949. Now we have paid it in the second year also, we are left with 3,623 principal. Now last third year, at the end of third year, on 3,623 we need to calculate 9%, that is 326. And here, so 326 plus 3,625, that will be equal to 3,951. Both this interest and principal repayment column, if you will add this, you will get the payment. Payment will be same. payment is installment. Installment will be same because that will be equal for each period, but interest and principal will be different. It has to be calculated on the outstanding balance each year. So now 3623 minus 3625. Oh, 3623 minus 3625 will get minus 2, but minus 2 is just nothing. Here 0 should come. Here 0 should come in the last. Okay, maybe minus 2 is coming because of that rounding of the decimals. So if you will take decimals also, that's fine, that's completely fine. Here 0 should come here in the last, in the balance column, in the last 0 should come. So this is how we can create loan amortization schedule. We can create means first we need to calculate EMI, or we need to calculate equal periodic installments we need to calculate, and that equal periodic installment will go in the payment column in each period. That will be same. Initially it will be nothing, 0, nil. Then interest and principal repayment, it is nothing, just the big breakdown of this 3951. That's what I was telling you, ki this loan amortization schedule, with the help of this we get the breakdown of this 3951 rupees, this installments, this equal installments, we get the breakdown. So at the end of first year 900 and 3051 is the interest and principal breakdown. At the end of second year also, third year also, we got different interest and principal repayment breakdowns. That can be different, but installments will be same. And in the beginning the outstanding balance was 10,000, so we need to subtract from this outstanding balance, we need to subtract the fourth column at the end of each year. So 10,000 minus 3051, then 6949 minus 3326, then 3623 minus 3625. Simply we'll get in the last 0 we'll get. So this is how we can solve loan amortization schedule. We can create this table. I hope this is clear. Like this same, you can solve this question, you can go for this question. That's it. Thank you.